Let's take a look at another example. Home loans are normally distributed with a mean of $370,000 and a standard deviation of $50,000. What is the minimum amount requested for the largest 5% of the loans? So what exactly are they asking you for here? So let's see, the mean is $370,000. Let's label that on our sketch. So the mean is equal to 370K. And the standard deviation, or the measure of spread, is $50,000. What they would like to do is they'd like to know what is the minimum amount requested for the largest 5% of the loans. So where are the largest 5% of the loans going to be? Well, the largest 5% of the loans are going to be over here in this tail here. So these are going to be representing the largest 5% of the loans. And the other remaining area under this curve is going to be 95%. So we've got 95% to the left of this particular x value, and 5% will be to the right of that x value. What area would I be looking up for in my z tables or in my normal tables? And remember that the z value is going to be x minus the mean over the standard deviation. So I have the mean and I have the standard deviation, but I don't have the x value and I don't have the z value. I need an area to get a z value. So what area would I be looking up? Well, if this is 95%, that's to the left of that x value, then that must mean that this is 50%, and this must be 45% to give me the top 5% for the largest 5% of the loan. So now I'm going to go to my Z tables and look up an area that corresponds to 45%, and that will be the area between the mean and the x value. And so now we need to scan our normal distribution tables and see if we can find an area that is as close to 45% as possible. And from that area, then we will get our Z value. So I'm looking in here and I'm saying, oh, this is 43.7%. So I'll look a little bit further. Here's 44.84%. I'm getting a little closer. And when I move next door to that, I get 44.95%. That's just a hair under 45%. And when I move next door to that, I get 45.05%. So that's 0.05% higher than 45%. And this one is 0.05% lower than 45%. So I've got two Z values, and it's pretty much equidistant from both of them. So I'm going to write both of them down. This 44.95 corresponds to a Z value of 1.64, and the other area of 45.05 corresponds to an Z value of 1.65. So I'm going to write both of those Z values down and see how I will deal with them. And so for an area equal to 45% of the area under the curve between the mean and that value, I've got one Z value of 1.64 and another Z value of 1.65. So wouldn't it make sense, just because it was equidistant, why don't I just take the halfway point or the midpoint between the two? So between 1.640 and 1.650, I'm going to use a Z value of 1.645. So that means that it's exactly halfway between the two. So now I've got a Z value of 1.645 is equal to x minus the mean, which is $370,000, divided by the standard deviation, which is $50,000. So I'm going to multiply both sides by $50,000, and I'll end up with 1.645 times $50,000, which is $82,250, and that's equal to x minus $370,000. Now I'm going to add 370 to both sides, or 370,000 to both sides, and so x will be equal to 452,250. So what is this telling you? This is telling you that at $452,250, okay, we will have 95% of the people will be borrowing less than that amount, and 5% of the people will be borrowing at least $452,250. So the highest 5% of the loans will be greater than $452,250. Now let's take a look at the next question, which is what is the maximum amount requested for the smallest 10% of the loans? So where's the smallest 10% of the loans? Well, let's see. Again, always identify the mean and the standard deviation. The mean is $370,000, so the mean is equal to $370,000, and the standard deviation is $50,000. So the smallest 10% of the loans are going to be over here somewhere. So let's just say these are the smallest 10% of the loans. So what does that tell you? If that's the smallest 10% of the loans, then that means that the others are 90% of the loans. Or in other words, I'm going to split that up into 50% to the right of the mean and 40% to the left of the mean because, well, 40% to that line where we have the smallest 10%. So I need to know what that X value is. And I know that that X value is going to be less than $370,000. And the formula that I'm going to use is going to be Z is equal to X minus the mean over the standard deviation. Problem is I don't have a Z value. I do know that the Z value is 0 here, but I don't know what the Z value is here. But I know it's going to be a negative Z value because it's to the left of the mean. So I need to standardize that. So how am I going to get the Z value? I get the Z value by looking up the area. And what area do I look up? I look up this area here of 40%. That area of 40% is going to give me the Z value that I need to answer this question. And so now I'm looking for an area of 40%. Now how do I find that? Well, at 0.9 it's 32%, so let's see, 1.25, at 1.25 it's 39.44%. That's pretty close to 40%. Let me go a little bit further. Now we have 39.62%, so it's getting a little bit greater, and 39.8%, I'm getting closer to 40%. 39.97%, that's 0.03% less than 40%. That's very, very close. And then the next one is 40.15%. So it's a toss-up between this number, 39.97, and 40.15%. Actually, it's not going to be too much of a toss-up. I like to keep it simple. It's not even halfway, so I'm going to accept the 39.97%. And that corresponds to a Z value of 1.2 and 8. So I'm going to accept a Z value of 1.28 as corresponding to my 40%, or it's at least it's as close as I can get. And now I have to go back and see whether it's a positive Z value or a negative Z value. Well, from my diagram, and it's my diagram that tells me that it has to be negative because it's to the left of the mean. So that Z value that corresponds to a 40% area is going to be negative 1.28. And my diagram tells me so. So we'll have negative 1.28 is equal to the X value, which is not known, minus the mean of $370,000 divided by the standard deviation of 50. So I'm going to multiply both sides of this equation by $50,000. So 50,000 times negative 1.28 works out to be negative 64,000. And that's equal to X minus $370,000. So now I'm going to add 370,000 to both sides of the equation, and I end up with X is equal to 306,000. So what does that tell you? That tells you that we've got $306,000 to the left of the mean, and we know that 10% of the loans will be less than $306,000 and 90% will be greater than $306,000. So 10% of the loans will be less than $306,000.